Java is an object-oriented programming language. Objects are structures which contain data in the form of fields and methods. These fields and methods can be utilized in other classes by creating an object. Let's write a class that describes the fields and methods of a rectangle. Then we'll write another class that creates instances of the rectangle class to find the total area of 2 rooms. I've created this new class called Rectangle, and we're going to create some fields and methods inside of Rectangle. Now, if we think of Rectangle as not just a class, but as an object, we could come up with some different characteristics that a rectangle would have, as well as some actions that can be performed on a rectangle. So if we think about some characteristics, let's say a rectangle has a length and a rectangle has a width. So we can declare these as global variables, or are also known as fields. So now that we have the fields of a rectangle, what are some actions that can be taken on these fields? Well, we can calculate the perimeter of a rectangle. We can also calculate the area of a rectangle. So the methods within an object perform some action. So let's create those two. Okay, so for the calculate perimeter method, we need to return a double. So we're going to calculate what's the perimeter based on the length and width, and we'll return that back. The formula is 2 times the length plus 2 times the width. And for the area, the formula is simply length times width. So we can return that. This is a very simple class to represent an object. Notice that this class does not have a main method. We're not interested in executing any of the methods inside of this class. This class is made to be a general representation. So if I were to represent a general rectangle object, what would that look like? Well, it would have the length and the width, and you'd be able to calculate the perimeter and the area. This blueprint is meant to be a generalized shell that we could then later on in other classes make more specific. But before we do that, let's talk about some of the other components of a class. We have the fields and we have the methods. However, we have no values for these. For example, if someone were to call this calculate perimeter method, we have no idea what the value of length is to be able to multiply it by 2, or the value of width. So we have to provide some methods that will allow whoever's using the rectangle class as an object to set the length and the width to what it is that they want it to be. There are a couple of ways that we go about doing this. One is to provide getter and setter methods for each of the fields. So we can create a method that will allow anyone who wants to use a rectangle object to set the length, or get it if they want to read it, as well as the width. So I'm going to make a couple of more methods here. I'm going to say double get length, and this will simply return the length. And we're going to say void set length, and this one will take in a parameter, and we'll call this length as well. Now remember, we learned in the last chapter about the scope. So this length is not the same as this length. However, we want to set whatever value is being stored in this length to this length. So we can use this keyword, this, dot length equals length. The this keyword refers to this class, and it's essentially saying to take the variable that belongs to this class, which would be this one. We're going to take this as the memory location, and then we're going to take our scoped variable of length, take its value, and store it inside of this class's version of length. Now, again, we learned in the last chapter that as these things map, they do not have to be the same name. We could have very well have called this L, and that would work as well. But it's convention to go ahead and name them appropriately. And length is an appropriate name as long as you understand scope. Let's now make getter and setter methods for the width. So again, if you're asking to get the width, we're just going to return width. And if you want to set it, we'll take in a width. And we say this class's version of width should be equal to the width that was just passed to us. Now you might ask, well, Angie, why did we use this .width here, but not here? The reason we had to use width is because of the scope. If we were to just say width right here, it would think we were still talking about the width that's within our scope. And essentially we're setting the same thing equal to each other. But this is not the variable that we are talking about. We're talking about this one in that case. So we use the this to specify exactly which of these we're talking about. Okay, so getter and setter methods, that's one way that people who create the rectangle object can set these values, but there's also another way that's called a constructor. All objects have a constructor. So let's talk about a couple of these. The very first type of constructor is the default constructor. Now constructors start with an access modifier, so we'll say public, and then there's no return type because they're not a method, even though they kind of act like one. And then you follow this with the name of the constructor. The constructor's name must be the exact same name as the class. So this must be called rectangle. We follow with a set of parentheses that can optionally have a list of parameters and then a body. The default constructor is known as the default constructor because it does not have a parameter list. This means if someone wanted to create a rectangle object and they did not want to set the length or the width just yet, then they can use this constructor without passing anything. And what the default constructor is typically used to do is to assign default values to the fields. So in this case, we can say the length is 0 and the width is 0. So we're giving this default values. Constructors are used to initialize an object or set up its state in some way. So if they were to call us without setting anything, we would just go ahead and set these equal to 0. Why don't we have to use the this word here? Well, we don't have to because we don't have a variable in this scope called length or width, so it's very clear that we are talking about the ones from the class. Let's make another constructor. You can have however many of these constructors you want. All of their names must be exactly as the class name. What differs is the parameters that they accept. So let's create another constructor for people who would like to create a rectangle and they actually do know the length and the width. Well, this time we can say, go ahead and pass us a length and pass us a width, and we'll set those values for you. So in this case, we can do a couple of things. We can say this dot length equals length. We're using this because we have two variables here called length, one for this scope, one for the class. Or we can simply call this method setLength, which does the exact same thing. So let's do that. And we pass it this length and setWidth and pass it the width. As a matter of fact, I want to leave this as this dot length, just so I can demonstrate to you that you can use either one. So let's say can be set this way or can be set this way. These are only different here to demo alternative options. Okay. Another thing about classes is that they should practice encapsulation. Encapsulation is one of the key principles of object-oriented programming. And what it says is when you create a class that's going to represent an object, then your fields should be private. So we've seen public before, now we're introducing private. What private means is that no other code outside of this class can access things that are marked as private. So no class can directly access this length, nor can they directly access this width. That's what the getter and setters and the constructors are for, to allow this class itself to determine how these things get set and how they are accessed. In order for these methods to be called, however, they must have an access modifier. Right now, with no access modifier, only classes within Chapter 6 can access these methods. If we wanted classes that were outside of this package to be able to access this, we would need to make these public. So encapsulation says to make your fields private and make your methods that are used to access those fields public. So let's do that. Now these two methods are not to necessarily access the fields. However, they will need to be called from outside of the package. So we can make these public as well. Notice in both of these, they do not accept any parameters. Why not? Because they're going to use the fields that already belong to this class. So when I create this object, if I already give you the length and the width when calling the constructor, then you know what it is and you can go ahead and utilize it. So we've looked at private, we've looked at public. There's another one that's called protected. If anything is marked as protected, it means that other classes within this same package can access it. It's similar to having no access modifier at all. Okay, so this is a representation, a blueprint of a rectangle class. Let's go ahead and make another class to see this in action.